Welcome to the second session on basics of Python programming. So in this session, we are going to discuss about collection data types in Python. So in the first session, we have seen identifiers, variables, keywords, operators, then some of the inbuilt functions, very useful inbuilt functions like range, div mark, those and how to convert from one number system to other number system. Those functions we have seen. So in this session, the focus will be on something known as collection data types. So collection data types, the name collection itself indicates that these data types includes collection of objects. So earlier we have seen integer, floating point variable, integer variable, string variable. They store a single value, either an integer, either a floating point value, a single value, that too. An integer, only one value. A floating point, only one value. A string, one string it will store. But these data types, they store a sequence of objects or collection of objects. That's why these are called collection data types. So basically Python supports different collection data types. Like it supports a collection data type called lists. It supports something known as tuples. It supports something known as dictionaries. Dictionaries. And then it supports something known as strings, lists, tuples, dictionaries. It is not. And it also supports some collection data types known as sets, dictionaries, okay, and sets. So we'll see these collection data types in this session and upcoming sessions. So we'll start with lists. So what is this list? So list is one of the collection data type, which is most commonly used collection data type in Python. So it will be useful in many of the applications. So first we'll see what is this list, how to define it, what it will store. First let me tell you, before going to the details about this list data type. So suppose you want to create some list. As I mentioned at the beginning, these collection data types holds sequence of objects, collection of objects. So then you can relate this collection data types like you can recall that array in, let us say, other programming language. It also holds a sequence of values, not a single value, right? But the difference here is this collection list. Let us say, first let me tell you how to define a list. Suppose you want to define some list. You define like this, square brackets. Anything that is between square brackets in Python, it is a list that you have to understand. Anything in between these square brackets, it is a list. So a empty list can be defined like this: a equals to open and closed square brackets. Now you want to give a sequence of values. Give a equals to, let me give 3, 7, 9, 15, 56, like this. These are sequence of values. Okay, now you may ask, what is the difference? This is like an array in other programming languages, right? Let me print also for you. You see, it contains 3, 7, 9, 15, 56, and so on. So the list data type supports heterogeneous items, not necessarily homogeneous, not necessarily all integer. You can define a list with 2 integers, 2 floating point values, 3.7, let me define 3.7 and 8.9, with and 2 strings you can define. The strings I will define later. So Bala, then Wow. So it holds not homogeneous, heterogeneous items, integers, floating point items, strings, and so on. So let me print it for you. It holds, see, it holds integers, it holds floating point numbers, it holds strings also. Now the next thing is lists in Python are ordered. What do you mean by ordering? Since they are ordered, you can access these elements by indexes. Suppose you wanted to access the first element of this list. So in Python, the indexes start with 0. So a of 0 will give you 3. This is called indexing. You can access individual items using indexes. So first item is 0, second item is 1, third item is 2, and so on. So 0, 1, 2, 3, 4, 5. Let me show you what is a of 5. What is a of 5? A of 5. It is raw. Okay. Now, the other advantage of this list in Python is that it supports negative indexing. What do you mean by negative indexing? Suppose you wanted to access the last element of this list A. So you can access the last element using a negative index -1. So -1 stands for last element. Now you may ask, so here 0, 1, 2, 3, 4, 5, 6. So if I give a of 5, it will also return the last element. What is the need of using this negative indexing? A of 5 will give you the last element. A of -1 also will give you last item. What is the advantage of using negative indexing over this positive indexing? So the advantage is that, suppose in this case, this list contains only 6 items. So with A of 5, you can access the last element. But if you don't know the length of the list, and if you wanted to access the last element, how you will access? In that case, you can access the last element using this negative index A of -1. So when this is -1, what is this? This is -2, this is -3, and so on. So you can access these elements using negative indexing also. So let me access A of -2, then you will realize the power of this negative indexing. A of -2. A of -2 will give you Bala. That means A of -2 means second item from last. -1 means last item. -3 means third item from the last, and so on. Okay. Then, so in addition to this indexing, Python supports something known as slicing. So slicing means what? You can access a sequence of items from this list. You see, it has the sequence of items: integers, floating point numbers, strings. Now, suppose you wanted to access this slides. That means from here to here, I wanted to access this one. So using this idea of slicing, you can access this slice of this list. How to access? You see the index. What is the index? It starts from first index. This is second, this is third, this is fourth. So using slicing idea, you can access this slice. So starting from second up to 4, let us say. Let me see, let me show you what it will give. So it will give from 2 to 3 only, but not including 4. If you give 2 to 5, it will give from 2 to 2, 3, 4. 5 will not be included. You see what is 2, 3, 4? So this is 0, this is 1, so this is 2, 3, 4. That's why it has written 3.7, 8.9 and Bala. So this is called slicing. You can access a sub part of the list using this idea of slicing. Now the next thing is, suppose let us say A of 0 to 5. What it will give? A of 0 to 5? It will give everything, entire list. Now you can use step also, step length. You see, now this is called step length. Now index starts from 0, so it will access element at 0th index, then the step length is 2. So it will access element at second index, then it will access element at 4th index, and so on. So 0, 2 and 4 will be accessed. 5, anyhow it will not include 5. So let me run this one now with step length. Now you see 3, 3.7, Bala. That means 3 is here, 0th index, 3.7 means 2, index 2, Bala means index 4. Okay, so this is called slicing. So similar to indexing, In slicing also you can use the negative index. Now how to use negative index? Let us use negative indexing here with slicing. Let us say I wanted to return last 3 elements in the list, -1 to -3. -3 means okay, -4, so that it will not include fourth element, right? Like here, 0 to 4, up to 4 only. 5 will not be included, right? Similarly, -1 to -4, so it will return last 3 elements. So if you run it, what you got? You got a empty one. But what we are expecting? We are expecting last 3 items in the list. But why it is not returning? It is not returning because if you see here 0 to 5, what it has returned? It has returned from 0 to 4. So it was assuming that the step length is +1, +1. That's why it was not returning. So if you want to go backwards, you have to give. So after -1, you want an index of -2. So you have to give a index. You have to give a negative index, -1, step length of -1. Then it will give last 3 items, Rao, Bala and 8.9. You see here the list. These are the last 3 items in the sequence, Rao, Bala and 8.9. So these are the ideas of slicing and indexing in Python. So by using indexing, you can access individual items. By using slicing, you can access a part of the list. You can access. So you can define two-dimensional lists also. Now let me define a two-dimensional list. So since we are defining list, I am using the square brackets. I am using two-dimensional list. So I use two-dimensional list. So here you see the outer square brackets are for 1 dimension. Now inside 1 dimension we are defining 2 dimensions. So it is like this is the first row, this is the second row, and this is the entire list. Let me define this list now. 1, 2, 3, 4. You can write different elements also, not necessarily all integers. So it is like a 2D array with the advantage of entering different elements of different data types, homogeneous elements. You see, so this is the first row, this is the second row. Now we can use indexing here also. Now how to use indexing here? X of 0. What is x of 0 will give you, like other programming languages, x of 0 will give you first row. X of 1 will give you second row. Now if you wanted to access first element of first row, then how you will access? Let me do it here. You want to access first element of first row, then first you have to go for first row, then go to first element. 0, 0 will give you first element of first row. 0, 1 will give you 0, 1 will give you 0, 1 will give you the second element of first row. So this way you can use indexing in two-dimensional lists also, 2D list, 3D list, any list you can use indexing. Slicing we have seen, right? Now we will see some of the built-in functions that are supported by this collection data type list. Now suppose you wanted to count the number of elements inside a list. So the list name, our list name is A. So if you want to count the number of lists, there is an inbuilt function called length. To this length you pass the list A. It will return that the number of elements inside the list A is 6. You see here, you can cross check. 1, 2, 3, 4, 5, 6. 6 elements are there in this list A. So that's why it has written 6. Similarly, it supports many other built-in functions. Now we'll see all these built-in functions. If you want to find minimum element in this list, so minimum element, but let me see. Let me define a list now with all integers. Let us say 1, 2, 3, 4, 5, 56, 78. Let us say. What is minimum of A? Minimum of A will give you A, 1. Similarly, if you want to find maximum element of this list, max of A, 78, right? Now we'll see. So unlike arrays in other programming languages, it supports elements of different data types. So the other advantage is that it is not static. You can add elements also. Now we have defined this list. So this list is not fixed. You can add more elements, you can delete elements from this list also. So it is not static one, it is dynamic. You can add elements when and as and when required. You can delete elements as and when required. So there are some inbuilt functions for adding elements, for removing elements. So we'll start with adding. So this Python, for adding elements, there are many built-in functions in Python. First, let us start with adding at the end. So if you want to add an element to this list, you simply call a dot append. There is an inbuilt function called append. Okay, now if you want to add some name, let us say, let me add now Bala. Okay, you can add it at the end. So it will add the element at the end. Now let me show you what is there in A. See, Bala was added at the end. So this append function will add the element at the end. Okay. Now, as I said, it is heterogeneous. So far I have shown you. Okay, let me add a floating point number also. A dot append of, let us say, 5.667. What is there in A? 5.67 was added. Now what we will see is, can we add a list to the list? Yes. Let me define a list, small list. List equals to 3, 2, 1. Okay. Now let me add this list to this list A. I am adding this list to A. So if I add this list to A, what will happen? You see, I am adding. What is the result? You see, the list was added at the end as it is. That's why it is. That's why I mentioned that it supports heterogeneous elements, not only integers, floating point numbers, strings. The list itself can be added in the list, right? Now, if you want the elements to be added rather than the list, suppose I wanted to add all the elements in this list to append. I want to append all these elements to this A. How to add this? Because here it was added as a list. Now if we want to add elements rather than adding a list, then there is a function called extend. A dot extend to give the list. This function, what it will do? It will add elements. It will append the elements at the end. You see, 3, 2, 1 was added rather than adding them as a list. Now they were added individually. Element by element was added. Okay. Now suppose you wanted to find. So okay, we have added elements. Now you wanted to find some element, right? Suppose you wanted to find some element. So there is a function called index. You want to find index of that element. Let me give element. Let me give Bala. So it will return the index of the element. So Bala, what is the index of this one? 0, 1, 2, 3, 4, 5, 6. Now let me give, what if I give A dot index 1? You see, 1 was there at different places. So what it will give? The first location where the 1 was found, it will return that one. So 1 was there at the 0th location, directly it will return 0. So this way you can find the location of an element in the list also. Now, so far we have seen adding at the end, appending at the end. Now if you want to insert somewhere, I don't want to append at the end, I want to append at some particular location. Now how to add that one? There is a function called insert. Using this insert, you can add elements in between also. So let me add, okay, wow, okay. Let me add wow. Where I want to add at some location. So here 0, 1, 2, 3, 4, 5, 6, 7. So I mean 6th location I will add. So I will give 6 comma wow. Now let me show you what is there in A. You see, okay, this is 6th location. So 0, 1, 2, 3, 4, 5, 6. Yeah, at 6th location, 6th in index 6, the element was added. Now you see what happened earlier. What is the result? This is the result. Earlier this is the list. Now raw was added. All these elements were moved towards right. You see, the elements were moved toward right. So I don't want the element to be moved towards right. I want to replace. At 6th index, so I, by mistake, I have entered some number here. I wanted to replace. Now, how to replace? If I again insert, again it will move all these elements. It will not replace. How to replace? If you want to replace, you can use the indexing concept. A of, suppose this row I wanted to replace. I will write A of 6. I will replace with what I will replace? I will replace with refresh Python. Python I will replace. Okay, now you see what is there in A. It will replace rather than inserting. Right. Now it was replaced with Python. So this is for inserting. So now we'll see functions for deleting. So basically, you can add elements. You can create a list. After creating a list, you can add elements. You can delete elements also. It is dynamic, right? So this is called mutable. Mutable means you can change the list. You can add elements. You can delete elements. You can do whatever you want. Okay, now we'll see how to delete elements. So far we are seeing how to add at the end, how to add at a location. So this much is enough. Now we'll see how to find an element also we are seeing using index function. Now how to delete elements. So there is a function called pop. What this function will do? It will return the last element. You see, the last element was returned when you apply this pop function. Now you may ask, okay, similar to insert, is there any function to delete from a particular location rather than from the ending? So this pop itself will support. You can pop from a particular index. Suppose I wanted to pop this Python. Let us say, I wanted to pop Python. So you give 0, 1, 2, 3, 4, 5, 6. I wanted to delete from index 6. You see Python. So let me show you what is there in A now after deleting. They are deleted. You see Python was deleted, 1 was deleted. Can you see? And one more thing I wanted to emphasize here is that it supports duplicate elements also. You can enter duplicate elements also. You see 2 was entered 2 times here. Right. It supports duplicate elements also. It supports heterogeneous elements. It supports mutability. You can change the values. You can insert values, you can delete values, means everything you can do. Not only adding and deleting, you can update also existing values. So this is about pop. So now, so using pop, you can remove the last element or you can remove based on index. Now suppose I wanted to remove based on element. I wanted to remove based on element. You see, I want to, okay. Here you see I wanted to remove Python, I have searched for index 0, 1, 2, 3, 4, 5, 6 and so on. Then I deleted. Rather than that way, I wanted to directly delete based on element. I directly give the element, Bala, I wanted to remove. So this is the command, remove. Now you see after removing, Bala was removed. Right? So similarly, you can remove, let us say a dot remove. We will remove that list, let us say. You give that list 3, 2, 1. 3, 2, 1. Let me delete. It was deleted. Now let us see what is there in here. So you can remove a element also. No need to search for index and delete. You can directly remove the element also. So there is a function called delete also, which will do the function of pop. So using this delete, you can delete based on index also. But I am not going to discuss because pop itself is enough. Pop will delete last element. Pop with index will delete an element from a given index. This remove will delete an element. You can specify the element, it will delete. Similarly, you see for inserting, append will add at the end. Then insert will add at a particular position. It will add at a particular position. Then you can replace also using indexing. So based on the functions that we have discussed, one can realize that the operations of stack can be implemented easily using list, because you see you can add an element at the append. Using append you can add an element at the end. Now you can delete the last element using pop. So this is like pop function, this is like, so this append is like push operation. So all the stack operations can be easily performed using list. Suppose so if you want to implement some stack thing, then that can be easily implemented using this list in Python. Similarly, if you see, you are not only inserting at the end, you are inserting in between also, right? So it is like linked list. You are inserting in between. Not only you are adding, not only the list is growing, you can add elements in between also. You can update the elements in between also, right? Directly with a based on index. So these are the functions, inbuilt functions that are supported by Python. So similarly, there are many other inbuilt functions. Suppose let us say this is the list. Now you wanted to let us say sort this list or revert this list. So there are inbuilt functions for this also. Let us say a dot sort. I wanted to sort this list. Where is the result? Result. I think. Okay. Let me print it. I think it was sorted. Let me show what is there in here. Yeah, it was sorted. You see, this is the list. I have performed this sort operation. Now this is the result. You see 1, 2, 2, 3, 3, 4, 5, 0.67, 56, 78. It was sorted, right? Now if you want to sort in, this is in descending order. If you want to sort in ascending order, then you write a dot sort. There is an argument called reverse. Reverse equals to true. You have to give reverse equals to true. So using this, you can, now let me show what is there in here. You see, it was in descending order now. Earlier it was sorted according to ascending order. Now it was in descending order. So similarly, you can reverse the list also. Suppose this is the list. Now you wanted to reverse this list. Reversing list means what? Okay, it should come in the other way. So right, okay, a dot reverse. Now let me see what is there in here. So we have reversed. This is the result after sorting in descending order, that we have reversed using reverse function also. So this is about this collection data type list. So the advantages are like, you can store heterogeneous elements. You can access individual elements using indexing. It supports negative indexing, right? Then it supports slicing. A part of list can be accessed using this slicing. And then it supports many inbuilt functions for finding the length, for adding elements at the end, for adding elements in between, for deleting elements from the end, for deleting elements based on index, for deleting based on element, all these things. And there are inbuilt functions for sorting, for reversing the list. All these are supported by this collection data type list. Okay, in the next session then we'll see the other collection data types such as dictionary, sets, and then tuples.